Question 15. State if the following statements are always true, sometimes true, or never true. Well, very interesting cases. Case 1. A rational function will always have at least one discontinuity. B. Inverse of even relation is an even relation. And C is a function that is always increasing cannot have any symmetry. A function that is always increasing cannot have any symmetry. Well, copy the questions, read them once again, and then try to answer them. They're kind of tricky questions, right? A rational function, I hope you remember what a rational function is. Rational functions are of the form of a polynomial divided by another polynomial, right? It's a quotient of two polynomials, correct? Where denominator cannot be zero. So that gives us restriction. Now, but is it necessary that denominator will always be zero? This is what you have to think. If it is zero, then there is a restriction, right? And then there will be a discontinuity. Have you seen a graph like this for a rational function? Something like this. Here, there is no discontinuity, correct? This is graph of a function which could be like f of x is equals to 1 over, let us say, x squared plus 1, for example. So x squared plus 1 will be a function like this, right? Now since there are no x-intercepts here, so this function is never 0. So x squared plus 1 is never 0, right? So you see in the denominator, it is never 0, and therefore there is no discontinuity in this case. Correct? So it is not always true. Well, most of the questions will have discontinuity. And you know, the discontinuities could be of a whole, of a vertical asymptote, right? So both discontinuities could be there. But there could be many functions like this where there is no discontinuities, right? So amongst these choices, statements are always true. So it is not always true, right? Sometimes true or never true. So we'll write this statement is sometimes true, right? Well, if I ask this question in true and false, then the answer is, of course, false, right? Because if you can give one exception to the rule, then the statement is not valid. Correct? Next statement. Inverse of even function is an even function. Is it always true, sometimes true, or never true? Well, here, let's take an example. Again, even function, let me take our parabola. That's a very good example. So y equals to x squared is an even function, right? Can you draw the inverse of this? So when you draw inverse of an even function, or any function for that matter, it is reflected on the line, right? Which is y equals to x. Now if I reflect it on this, you get kind of like this, right? Which is square root plus here and minus here. So is this function even? No, it is not, right? So this relation is not even, correct? So therefore, inverse of a relation is an inverse of even relation is an even relation? No, not at all. Correct? Now, one exception is there to this rule. The exception is the only function which is both even and odd. And that function is, exception to this rule is our function f of x equals to 0. Now that function f of x equals to 0 is kind of x-axis. Do you see? It's just the x-axis. Now if I have inverse of this, then it becomes y-axis, correct? Now y-axis is not a function, but it is symmetric about its own axis, right? Correct? So it could be even, right? So it's not a function though. So the inverse is not a function, but we are talking about even relation. Do you understand relation? So if it is even relation, then that is an exception to this rule. Therefore, the answer is sometimes true for this also. This is the only function which is an exception to this rule, right? Well, you could make some functions which are even and where it could flip in, but this is one exception, right? Now, part C. A function that is always increasing cannot have any symmetry. This equation, is this statement true? Always true, sometimes true? What do you think? If the function is always increasing, can you give me examples of functions that are always increasing? Let's take this line, right? Y equals to x. This line y equals to x is always increasing, right? And it is an odd function. Do you see that? Cannot have even symmetry is a wrong statement, right? Well, most of the odd functions you'll find are increasing. For example, how about x cubed? This is x cubed, right? It is always increasing. It is an odd function. So always increasing functions may have odd symmetry, correct? So this statement is false. So function that is always increasing cannot have any symmetry. So this statement is false, right? Okay, so these are our answers to the question. I hope you understand with this some tricky ones, correct? Okay, thank you.